Problem 16. An efficient rectangular section has fixed hydraulic properties such as area, roughness coefficient, and slope. Determine the percentage increase in discharge retaining the given hydraulic properties if the section is replaced by an efficient triangular section, trapezoidal section, and the most efficient of all efficient sections. So first, let's evaluate the discharge of a efficient rectangular section. Remember, the width base is 2D and the depth is D, so base is 2D, that's the proportion. Therefore, the depth of flow is, in terms of the area which is fixed, is square root of A over 2. Then the formula for discharge is area to the 5/3 S to the 1/2 over N perimeter to the 2/3. So substituting, by the way, the perimeter is 4D, 4 times depth of a efficient rectangular section. After we derive it, the proportions for efficient rectangular section. So, and D is square root of A over 2. Therefore, the perimeter is 2 square root of 2 times square root of A. Substitute into the formula. So, A to the 5/3, which is fixed, S to the 1/2 over N, 2 square root of 2 square root of A to the 2/3. So, since square root of A to the 2/3 is A to the 1/3, A to the 5/3 minus A to the 1/3 is A to the 4/3. So, therefore, Q of rectangle is A to the 4/3 S to the 1/2 over 2N. So, that's the discharge formula of an efficient rectangular section. For an efficient triangular section, remember the apex angle is 90 degrees, the top width is 2D, the depth is D, so the perimeter is 2D square root of 2. So Q rectangle is 0.5, 1/2 or 0.5 of area to the 4/3 S to the 1/2 over N. For an efficient triangular section, the area is D square, 1/2 of 2D times D, remember the proportion. So that means D is square root of A. The perimeter is 2 times D square root of 2. The slant side is D square root of 2, so times 2. So 2D square root of 2, replacing the value of D, which is, so 2 square root of 2 times D, and D is square root of A. So that means the perimeter of an efficient triangular section is the same as that of the efficient rectangular section. So Q of triangle is A to the 5/3 S to the 1/2 over N times 2 square root of 2 square root of A to the 2/3. So they have the same result. Q of efficient triangular section is A to the 4/3 S to the 1/2 over 2N. Therefore, the percentage increase if we replace the efficient rectangular section by an efficient triangular section is 0%. So that means an efficient rectangular section or channel is equivalent to an efficient triangular section, or they are equally efficient as anticipated in the lecture part, and we have proven it here. So having fixed area, of course. For trapezoidal section, so this is a semi-regular hexagon. All sides are equal. The angle is 30 degrees. The top width is equal to the sum of the slanted sides, because this is B sine of 30, 0.5 of B, 0.5 of B, so 0.5 of B plus 0.5 of B plus B is 2B. So that proves that for an efficient trapezoidal section, the top width should be equal to the sum of the non-parallel sides. The area is equal to 1/2 of quantity 2B. By the way, the depth of flow is, in terms of B, is B cosine of 30, or square root of 3B over 2. The area, the perimeter is 3B, B plus B plus B. And the area is 1/2, because area is fixed, common to all these sections. 1 half of 2b plus b times d, and d is square root of 3b over 2 in terms of b. So that is 3 square root of 3 over 4b squared. That's the area. Then expressing b in terms of area, b is 2 square root of area over 3 to the 0.75. Therefore, the perimeter is 3 times b, 3 times 2 square root of a over 3 over 0.75. So it is 2 times 3 to the 0.25 square root of area. So substitute in the formula for discharge. Q equals area to the 5/3 S to the 1/2 over N, then perimeter quantity 2 times 3 to the 0.25 square root of A to the 2/3. So evaluating 1 over quantity 2 times 3 to the 0.25, then close quantity raised to 2/3 in decimal. So Q of an efficient trapezoidal section is 0.52456 of area to the 4/3 S to the 1/2 over N, which is common to these values here. So we will not write that anymore. Anyway, it will be cancelled. So percentage increase is 0.52456 minus 0.5 divided by 0.5 times 100%. So this shows that an efficient trapezoidal section is more efficient than the efficient triangular and rectangular section, because the efficient rectangular and triangular sections are equally efficient. So percent increase in Q, if we replace the efficient rectangular and efficient triangular sections by an efficient trapezoidal section, is 4.912%. And finally, for the most efficient sections of all, which is semicircular, the area is pi r square over 2. So that means the radius is square root of 2a over pi, or square root of 2 square root of a over pi over square root of pi. Then the perimeter is pi r, half circle. So pi r, and r is square root of 2a over pi. So it is square root of 2 pi square root of a. Substitute. Q of semicircular section is area to the 5/3 S to the 1/2 over N times quantity square root of 2 pi square root of a to the 2/3. So evaluating 1 over quantity square root of 2 pi raised to 2/3 in decimal, that's 0.54193 area to the 4/3 S to the 1/2 over N. Therefore, the percentage increase, if we replace the efficient rectangular section by a semicircular section, which is the most efficient of all, is quantity 0.54193 minus 0.5 over 0.5 times 100%, and that is equal to 8.386%. So that's it for this problem.